Let's discuss complex numbers. So a complex number is a number of the form a plus bi, where a and b are real numbers, and I squared is -1, so the complex unit. So this is what a complex number is. So let's see some examples. I could have 3 plus 4i, there's a complex number. I could have 2. 2 is a complex number because 2 is equal to 2 plus 0i, so 2 is definitely a complex number. Or I could have, I times pi. That's a complex number as well. You can multiply, divide, add, do all kinds of arithmetic operations with complex numbers. So for example, what if I had 3 minus I times 2 plus I? So you would expand this using the FOIL method or any other method that you know. I would multiply 3 times 2 to get 6, 3 times I to get 3i, minus 2i, minus I squared. This simplifies because I have 6 plus I, and then I have minus I squared. I squared is -1. So I actually have minus a -1 or plus 1. So it's really a complex number, 7 plus I. Let's do an example where I divide two complex numbers. So let's say I have 3 minus I over 2 minus I. The way to divide complex numbers is to multiply this expression by the complex conjugate of the denominator. So that sounds fancy. Let me show you what that means. That means to multiply by 2 plus I divided by 2 plus I. So what I did is I looked at this 2 minus I and I just changed the minus sign here to a plus. If you change the sign of the imaginary part, the part with the I, the B, if you change that from a minus to a plus or a plus to a minus, that's called the complex conjugate. And I'm going to multiply this expression by the number 1. See, this is the number 1 because it simplifies to 1. So I'm not really changing the number at all. I'm multiplying by 1. But the reason I do that is because now the top becomes 3 minus I times 2 plus I, and the bottom is a difference of squares. So I have 2 minus I times 2 plus I. That gives me the difference of squares if I expand everything out. And I will get 2 squared minus I squared. Now the top I just happen to have done in this previous example. So the top, if I expand, becomes 7 plus I. And the bottom becomes 4 plus 1 because I squared is -1. So I get 5. So I could write the answer as 7/5 plus 1/5 I. There's my complex number. That's how you divide complex numbers. Maybe it'd be nice to do one more example of dividing a complex number. What if I had 1 divided by 1 plus the square root of 2i? So again, the trick in dividing complex numbers is to multiply by 1 minus square root of 2i divided by 1 minus square root of 2i. Again, I'm looking at this, taking the complex conjugate by changing the plus to a minus and multiplying by the number 1 so I don't change the number. On top, I get 1 minus square root of 2i. And on bottom, I have the difference of squares trick again. So I have 1 squared, and then I believe I will get minus square root of 2 squared I squared, so 2i squared. And if you do a little bit of the simplification, I get 1 plus 2 on the bottom, so 3 on the bottom. I get 1/3 minus the square root of 2 over 3i. Now, the reason that we are interested in complex numbers in this class is because when we use the quadratic formula to solve a quadratic equation, we will occasionally get complex numbers. So here is an example. What if I had the equation x squared plus x plus 1 is equal to 0? Well, the quadratic equation says x is equal to -1 plus or minus the square root of b squared, so 1 squared minus 4ac, so minus 4, all over 2. And this is -1/2 plus or minus, and now if you look up here, I have the negative in a square root. So I have a negative in a square root. I can write this as the square root of 3 times the square root of -1 all over 2. And the square root of -1 is what we're calling I. Because if you square it, I squared, you'd get -1. So the answer is 1/2 plus or minus the square root of 3 over 2i. So sometimes when you get a quadratic equation, you will need complex solutions. So the question is when? So when will ax squared plus bx plus c equals 0 have a real solution? So sometimes you'll get a solution that's only a real number, like without the I, just the a, and sometimes you won't. Well, if you look at the quadratic equation, -b plus or minus the square root of b squared minus 4ac, the only place where you could possibly introduce a complex number is in the square root. So we get a real solution when this inside part, b squared minus 4ac, is bigger than or equal to 0. Okay, there's a very, very brief introduction to complex numbers. Excellent.